In this video, we are going to go over how to use distribution with the FOIL method and square roots. It's really like a review of where you've been with foiling and a combination of your square root knowledge. Let's check it out. So in letter A, the directions, as usual with square roots, is to simplify. So we have the quantity 2 minus the square root of 5 times another quantity 2 plus the square root of 5. What do we do? Well, this is set up a lot like if you had like x minus 5 times x plus 5, right? A lot like that. So we would FOIL if that were the case, right? You would do first, outside, inside, last. Let me erase all that. Just wanted to point that out. So looking at it that way, we're going to FOIL. We're going to distribute. Remember, FOILing is just a way to organize how we distribute. So first, outer. We'll do the first two there. 2 times 2, there's your first, is 4. Outer, 2 times positive root 5 is 2 root 5, or 2 times root 5. Now we're ready for our inner and our last terms, just using distribution there. So the inner is negative root 5 times 2, which is minus 2 root 5. Nice. And then minus root 5 times plus root 5 is minus 5. I'm going to go over that one briefly again. Root 5 times root 5 is root 5 squared, which is itself 5. It's minus because it's minus times a plus. If you're having trouble with why the square root of a number times the square root of that same number is going to be the number inside the square root sign, check out my earlier videos on squaring square roots. Okay, so now from here, 2 root 5 minus 2 root 5, they are like radicals, so they will subtract out and you're going to get 0. 2 minus 2 is 0, so we're left with 4 minus 5. All of that is negative 1. So these actually are called, here's a big word, conjugates. When you have numbers where you have a plus b and a minus b, the same two numbers, 2 minus root 5 is the a minus b, 2 plus root 5 is the a plus b, those are considered conjugates when you have the same two numbers but just opposite signs, addition and subtraction. Cool stuff. Okay, so on to this one. You have 2 root 3 plus 3, that quantity squared. So you use the definition of what it means to square. That means multiplying a quantity by itself. So you take that same quantity and multiply it out by itself. Nice. So now from here, we're going to use the distributive property. We're going to FOIL. So I've got first 2 root 11 times 2 root 11. Let's just write that out. We'll do that operation shortly. So that's first. Outer, 2 root 11 times 3. I'm going to do that mentally. 2 times 3 is 6 root 11. Nice. Inner. 3 times 2 root 11, 3 times 2 is 6. They're both outside radicals. So that's 6 root 11 again. And then last but not least, the last, 3 times 3 is 9. Okay, so from here now, let's do a little simplification. 2 times 2 is 4. Root 11 times root 11 is 11, right? The square root of 11 squared is 11. Plus 6 root 11s plus another 6 root 11s, combining like radicals there, is 12 root 11. Plus 9. So 4 times 11 is 44, plus 9 is 53, plus 12 root 11. And we cannot simplify any further. They're certainly not like terms. Nice. So moral of the story, FOIL. Simplify, combine like terms. It's not bad. It's like you're combining all of your skills of radicals all into one. We'll do one more and then we'll call it a video. All right. So in this one, I've got the square root of 7 minus 2 root 2, that quantity, times 3 plus 4 root 5. First, 3 times the square root of 7 does not become the square root of 21, right? It's 3 times the square root of 7. 3 is not underneath the radical, so just 3 root 7. Outer, that's going to be root 7 times 4 root 5. 7 and 5 share no common factors at all. So there are going to be no perfect squares that come out of it. Let's go ahead and multiply. Root 5 times root 7, both underneath radicals, is 35. Don't forget about the 4. So it'll be plus 4 root 35. Now let's do the inside. 3 is not under a radical, nor is 2. So minus 2 times 3 is minus 6 root 2. We'll keep going here. Last. Minus 2 root 2 times 4 root 5. Well, 4 times negative 2, they're both on the outside, is negative 8. Root 5 times root 2, we will multiply. Neither have a common factor. 5 times 2 is 10. Multiplying things under the radical there. So now we'll see if we can do any simplifying. 7 and 35. Well, 35 can't be reduced. There's no perfect squares in it, nor does 7. 2 has no perfect squares as a factor, neither does 10, which means that everything you see here is in simplest radical form, and none of them share the same radical, the same number underneath the square root sign, so we can't combine any terms. We're done. 4 terms in that answer. Foiling, square roots, fuse them together, beautiful thing.